In a recent survey, a random sample of 1,625 people shopping for a new car were asked whether they'd pay the sticker price for the car. Oh, period. 926 reported they'd wait for the salesman to make a better offer. So what value of Z should be used to calculate a confidence interval of 90% confidence? Okay, so when you calculate a confidence interval, you're trying to capture 90% in the center of the normal distribution usually. Okay, and for intro stats classes, we're usually just concerned with a bell-shaped curve. So you want 90% in the center. That means, or whatever percentage they're talking about, 95%, 99%, etc. So it means there's 5% left over for this tail over here and 5% left over for this tail. So when Newton gives you table values like this, or when you look up z-scores in a table, the table conventionally is always talking about the area to the left. So this is 0.10, so 10% of the area to the left. That's why we don't want this z-score. This z-score says there's 5% in the tails. So if you have a z-score of 1.645, that's to the right of the center at 0. Right? So this is saying that 5% exists in this tail over here, and a corresponding 5% exists over here. So what z-score? You just want 1.645 for this problem. Okay, and again, that comes from the tails. If we want a 90% confidence interval, we want 5% in each tail. So 5% in the left tail, 5% in the right tail. Okay, so that's tough because they don't explicitly say, hey, this is the area in the tail. There's some z-score tables that would say, hey, for confidence intervals, 0.05 is such and such a z-score. So, but with Newton, they're saying this is the z-score. And look, all this stuff actually didn't matter. In this problem, all this stuff up here didn't matter. They're just asking for what z-score should I have for a 95% confidence interval. Well, okay, if you want 95% confidence, that means you want 2.5% in the tails. In other words, as a decimal, it's 0.025. So this answer is 1.960.